refractive index of an equilateral triangular prism at minimum deviation. First of all, let's look at the diagram of a triangular prism. So let's start. This N1 here is the normal on the plane AC. Is the normal on the plane AC. Then N2 here is the normal on the plane AB. Then we have A that is here. This A that is here is the refracting angle of the triangular prism. Then this I that is here is the incident angle. Then the R1 here is the refractive angle of the ray of this ray. The refractive angle of this ray, that is the angle the refracted ray makes with the normal. This R2 here is the angle the refracted ray makes with the normal at plane AB. Then this E here is called angle of emergence. That is the angle the emergent ray makes with the normal at AB. So this ray here is incident on the plane AB and refracted through the prism, then emerges at the plane AB. Then there is an angle here. This is called the deviation angle. The angle the incident ray makes with the emergent ray. Okay. Now let's start. This triangle here, the sum of this triangle here is 180. We all know that sum of angles in a triangle is 180, but we don't know the angle here and we don't know the angle here. But we know that here is 90 degrees and here is also 90 degrees. So the angle here and the angle here will now be equals to, for the angle here, it will now be equals to 90 minus R1 plus the angle here will be equals to 90 minus R2. 90 minus R2 plus A, which is the angle here, this angle here, all is equals to 180. So from here we have the 180 minus, let's recall that at minimum deviation this angle R1 here is equals to angle R2 here. So since R1 is equals to R2, that is R1 is equals to R2, so let's call both R. Then when you are calling both R, so minus R1 minus R2 will be equals to minus 2R plus A, which is equals to 180. So minus 2R plus R. When 180 moves to the other side of the equation, it becomes minus 180, and 180 minus 180 is equals to 0. So A is equals to 2R. Then R equals to A over 2. So let's call this equation 1. Our equation 1. Let's proceed. So let us look for R. But first of all, we have to know that this triangle here is an isosceles triangle. So one exterior angle is equals to sum of two interior angles. So going by that way, we have that D is equals to B plus C. Then we have that B is equals to D minus C. Let's call it equation 2 and leave it. Let's also circle it here. Then to find I, we have to know that two opposite angles are equal according to trigonometry. So I is equals to B plus R1, and we have our B to be this. So I is now equals to D minus C plus r1. Okay, let's call this equation 3 and leave it. Let's circle it also. Now let's clean this. Let's continue here. Then we say that two opposite angles are equal. So from here and here, we have that E is equals to C plus R2. So C is equals to E minus R2. So we will substitute this here. Let's make some space. So let's continue. So substituting this here, we will have that I is equals to D minus our C is this, bracket E minus R2 close bracket plus R1. Then I is equals to D minus E plus R2 plus R1. And we remember that we said that minimum deviation that R1 and R2 are equal, and we take both of them to be R. And also we have to note another thing, that at minimum deviation I is equals to E. So we have that I is equals to D minus E. So since R1 and R2 are equal and we took them as R, so R plus R will be equals to 2R. Equals to 2R. So let's make some space to continue. Okay, let's go. And we say that E and I are equal, so we can represent both of them as I. So I is equals to D minus I plus 2R. So moving I to the other side of the equation, we have that it will move to be plus I instead of minus I. So we have that 2I is equals to D plus 2R plus 2R. So I is now equals to D plus 2R all over 2. So from here, let's make some space. So from here, we have that I is equals to D over 2 plus R. And let us recall that from our equation 1 here, that R is equals to A over 2. So from there, we have that I is equals to D over 2 plus A over 2. This I will be over 1. Let's find LCM. LCM is 2. So that 2I is equals to D plus A. Then this cancels. I is equals to D plus A all over 2. And at minimum deviation, this D is always represented with capital D. It's always represented with capital D. So we change it to A plus D all over 2. Let's recall that according to Snell's law, N is equals to sine I over sine R. And we have that our R is this, while our I is this. From here, we have that N is now equals to sine A plus D all over 2 all over sine A over 2. N is equals to sine half bracket A plus d all over sine half a. Thank you for watching this video.